Okie dokie. Okay, before we actually get into the lecture, I just want to point out a couple resources that are going to be useful for you guys as you come into working on ggplot and plotting for this particular week of stuff, and also stuff that's useful going back for Markdown and things like that. So on the course website, usually for each particular week, I have a whole bunch of extra links that are just sort of things if you're interested in, go and look at them, but nothing's usually required. If something is bolded in these, it's highly recommended. It's still not required, but it's highly recommended. In this case, the only thing I bolded for this week is there is a chapter on visualizing data in the book R for Data Science that I've linked to right here. This week's lecture is based on that chapter, and this class in general is based on that book. So this is a pretty good place to go for general stuff. The book is written by Hadley Wickham and Garrett Groleman. Hadley Wickham is the author of ggplot and dplyr and all these things, and Garrett Groleman is one of the people who's best at teaching this material. He teaches lectures on data camp and stuff like that. These are the best people at it. They've developed these packages. This chapter is great. I highly recommend everyone just read it. It's okay if you don't understand things in it, but go through it. It's laid out really nicely. And that's kind of looks like this. This whole textbook is available free online. You can download it as an HTML file or PDF, whatever. You can grab it, and it's a great course in sort of R for data science. Another thing that'll be useful that's linked on the slides, but I see I didn't put a link on the website. This is an example of an RStudio cheat sheet. So RStudio puts out these things they call cheat sheets for different packages in R. This is the ggplot cheat sheet. It basically shows every component you could possibly have in most ggplots that we're going to go. Doesn't matter you guys don't understand what the stuff is now. I want you to know that this exists. This shows all the different functions, ways you can display data using ggplot. And you'll see it has like a little picture of what that's going to kind of look like, the exact code, all the arguments to all these functions. And this is a huge PDF with a shit ton of information, right? This is the kind of thing that when I'm making a plot and I don't know exactly how to do it off the top of my head, first thing I'm going to do is open up one of these cheat sheets. If that is not enough for me to figure out what I want to do, what I'll do is I'll take information off of here and be like, okay, that sounds like what I'm after, but this doesn't give me enough information on how to use it. Then I'll go look at the documentation based on this. This is the first place I usually start on knowing how to do ggplots. There's cheat sheets like this for all of the major tidyverse functions, which I'm going to talk about, things like dplyr we're going to get into today and stuff like that. There's a cheat sheet for all of these things on the RStudio website. You Google RStudio cheat sheet, it'll take you straight to a web page that has tons of different cheat sheets for lots of different packages, and there's probably a cheat sheet for almost every package we're using in this class, major package anyway. These things are really useful. Okay, one other thing, somebody asked me when our peer review is going to go out. They're going to go out a little bit later today. I think I actually set them up to be automated. They might go out while we're during this class or something like that, but you should see them by the end of the night. If you don't get one assigned, it might be because there's an odd number of people in the class or something like that. We'll see, but they should go out tonight. If they don't go out for you, they probably didn't go out for anyone, so don't bombard me with emails on them. I'm definitely going to check and make sure they go out tonight, so they should go out. I haven't checked to see how many were turned in, stuff like that. I'm not too worried about it. Don't care too much. I'll see you later today. Okay. Are there any, before we start the lecture, are there any questions on class stuff in general, homeworks, anything like that so far? Yeah, they'll go out and it will assign it. And so I'm using it through Canvas has built-in peer review system. It will automatically kind of randomly assign, pairs people up. And so you'll get a homework from one person, but you won't get their homework. You'll get somebody else's. It's like a round robin type thing. But it's totally has a random number generator that does all that for it. So they'll just go out.
So we will go email or?
Yeah, it'll be emailed to you, and it should be a Canvas notification, and it will pop up in Canvas. So that's about the only thing I use Canvas for in this course are the homeworks and the peer reviews, because they've got a good automated system for it. Yeah, but it should go out. So at very least, you just check your Canvas tomorrow or something like that. These things should only take you 20 or 30 minutes. You don't have to hop on it right away, and they're not due until the next homework is due, which is Tuesday at midnight. So you got plenty of time. Okay, so Today's lecture is going to be on visualization using the GGplot2 package. GGplot2 is the dominant platform for visualizing data in R. It's basically what most people end up using. They don't necessarily all start with it. A lot of people start with base graphics. I started with base graphics. If you learn GGplot2 first, it's not going to be hard to go back and use base graphics if you want to, but if you learn base graphics first, it makes it harder to learn this. This is more intuitive and more powerful than base graphics. So we're starting with this, but it's easy to go back. And if you want resources for going back to base graphics, there's a great textbook I recommend, Merle's R Graphics, something like that. I think I have it linked on the website. Great book for base graphics. But pretty much everybody's using ggplot for just about everything except really finely customized graphics. If you're writing a graphics package yourself, actually if you write a graphics package yourself, you're also not going to use base graphics. You're going to be using grid. Grid graphics are what are underneath ggplot. So basically everybody's using this stuff. Okay, before we get to that though, I want to go over a few useful things that we're going to kind of want to know and are probably things people are wondering in the back of their minds or don't even realize that that's something they're wondering about. So, one thing that is people may have seen is that sometimes I'm writing code and it looks something like this. I say something like, okay, new object assigned 1 to 10, and then I have some text over here explain it. I'm just saying, oh, what I'm doing here is I'm making a vector of the numbers 1 to 10. Well, what this hashtag is here, or the pound sign, is the commenting symbol in R. If you want to write comments in your code of any kind, anything written after the pound sign is going to be shown in RStudio in green, and it will not be run. It will be ignored totally by RStudio, right, in syntax files, right? If you write it in a code chunk, it'll be ignored. It won't be run, anything like that. This is for documenting your code. When you write big files of syntax, you should document the things that you do if it's not incredibly obvious what you're doing. Most of the tidyverse packages that we use in this class, things like ggplot, dplyr, are designed in such a way that it should be immediately obvious what you're doing just by using those functions, so you might not have to comment your code as much. When you do complex things though, or even things that if you have any doubt that you wouldn't, if you think maybe if you went back in a year to this and you wouldn't know exactly what you're doing, write a comment for it. You'll thank yourself later. Document everything you do. I have lots of syntax files of my own that they're about half actual code and about half documentation. The ones that are not are the ones I go back to and end up staring at and scratching my head about for like an entire day. I'm like, it works, I have no idea why, and I have no idea like what it's even producing, but it's sure working. That is bad. Like, that's terrible, because if you have to make any modification to it, you don't know what the hell you did. So document your code as much as possible, or as much, I would say as much as possible. You could document it incredibly heavily unnecessarily. And this goes doubly to if you're going to be sharing your code with anyone, everyone's going to look at it, because people are really not going to know what you're doing, and everyone has idiosyncrasies in the way they program. Document your code. Do it with the commenting symbol. Yeah, anything on that same line will not be run by R if it occurs afterwards. Okay, next. You probably want to be able to save objects you create in R. I didn't cover that in the first week. I'm going to cover it now. So, you can save any R object you create in R with the save command. When I say an object, I mean anything. It doesn't matter what it is, you can save an object in R using this command. And since everything is an object in R, you can save everything you work with. Use the same code to save, say, a single function you could save that way. If you want to say, usually use it to save data sets, a data frame, lists or sets of data frames, that kind of thing. You can save single objects this way. The command, the function is just save. The name of the object as it currently exists in R. So if you want to save new object, which I created on this last slide, you just put new object here, and then you'd go file equals, assign it a name, and you'd usually make it a .r data file. That is a R binary file. It's an extremely compact way to store things. Say you take something like a gigabyte Excel file, like a really big database, you put it in and make it an R binary, it's going to be reduced to about 50 megs. 100 megs. Binary is very efficient for storing things, much more efficient than like formats that are actually storing them as the raw text and stuff. So I tend to save things as R binaries. And that's how you do it. You can also save or open files using the load command. So if you save this new object.rdata and you want to open it, you just do load new object.rdata. What it's going to do is it's going to open that file and it's going to load this object back in with the same name you saved it with into your R environment. The natural question from these two commands is, where is it saving and loading these things to and from, right? So the answer to that is working directories. The way R works is that R saves its files and loads files, looks for files to load, that is, in what it calls its current working directory. If you have R open, you want to know what your current working directory is, there's a command, get wd, no argument to it, and it will list whatever's the current working directory. This, for example, is the current working directory for this particular lecture. So you can see I've got it like in my OneDrive, this class lectures week 2. That was the folder that all of the files for this particular week's lecture are located in. If you want to set a working directory and make your R look in a particular place and automatically save stuff in a particular place, you just use setwd and then give it some kind of file path, right? Yeah, so I'm on a Windows machine, so I'm here on C user CCLAN documents. I just set it as an example. Yeah, I am not very Mac savvy, so you would want to go online and look for the best practices for like directory structures and stuff on Mac systems or on Unix systems. I'm not super savvy. Okay. For good practices for managing files and managing your projects, I think it's normally a good idea to give every project, and a project could be something like a single homework assignment, a single lecture, or something like that. Every one of those things should probably have its own folder. And if it's something like a homework assignment for this class, I would have that homework assignment in a folder called Homeworks, and I'd have that in a folder called CSSS508. Lots of directories are a good way to organize things. If you have lots of files in one particular folder that are all sorts of different things, it's hard to look for them, it's hard to figure out what it is. You should generally have either folders or files in a directory, not both. Make big hierarchies. This is important when you eventually accumulate a ton of stuff, as you tend to as an academic working in projects over a long career. You'll end up with hundreds and hundreds of projects filled with hundreds and hundreds of files. If you have the same directory structure for every single project you have and it's well nested, you'll never lose anything. You know exactly where to look. When I make a new project, I have a script on my computer. I run the script and it automatically creates a top-level directory with the project's name, and then inside it, it creates something for data, something for script, something for output, something for memos, all that kind of thing automatically, and then inside of those subfolders for all the appropriate things for that kind of stuff. You do something like that, every project you have is organized the exact same way. It's really nice. There are people out in the world who are obsessive about project management and organizing that stuff, and they actually teach it in a class from CSDE. CSDE 502 or 501 teaches some of this like directory structure stuff. It matters a lot when you get to be working on a lot of things. Yeah, my stuff sometimes gets out of control. If I'm lazy about it, it always comes back to bite me in the ass. So try not to be lazy when you're setting stuff up. So this is the system I use. Every class or project has its own folder. Assignments or tasks have a folder inside that. Name your .rmd and .r files clearly. Long file names are good. Things that are really descriptive, and ideally have everything have the same format to it. I name my files usually with the project, underscore the specific thing the script is for, underscore the date that it was written on. And that way I can have different versions of a script in it. I can glance at a file name and know exactly what it's for and what it does. I do it with my data, everything. It means I type a lot longer, but I never lose things.
So do you mean you set a new working directory every time you do something?
Every single one of my scripts starts with a set working directory command, and that's a good thing to do. When every one of your homework assignments, including your markdown documents, start them with a set working directory to wherever you're going to be working, and then it will look for things on that way. That's basically standard practice, that any kind of script for a project is always going to automatically set to the particular working directory. The only time you wouldn't do that is if you truly are working with a script that never saves anything and never loads anything locally, then it doesn't really matter too much, and that's really only going to be the case for things like microsimulation and stuff like that. But if you're doing that, you know what you're doing, so you don't need to listen to me. Yeah, so for example, this presentation that I'm showing today is located in this location on my computer. So I have all my stuff on my GitHub, because this is where my stuff is mirrored online for this class. I have for this class lectures week 2, and then this lecture is named CSSS508 week 2 GGplot2.rpress. So I can glance at that. I could lose that file anywhere on my computer. I know exactly where it goes, what it's for, and what we're going to be covering in the day. It's a good way to do it. It's a pain in the ass to type, but it's great. It really sucks to have a whole bunch of things that are like new file, new syntax, new script, all over, then you have no idea what the hell anything is. test. I actually end up with a lot of objects called test. Luckily, when you're programming in RStudio, you can find replace, Control F and find replace. So if I do it something like test, I end up using it a lot, I find replace the entire document like that, and so you can change stuff. That's nice. Automating repetitive tasks is what programming is for. So use whatever system you want, but be consistent, and avoid losing your work by overwriting files. Longer file names are good because you're less likely to name two things the same thing. If you name lots of things test, you're going to end up writing over a lot of tests. Okay, rant over. Oh yeah, one last thing actually. RStudio also has built-in project management system. So in the top right of RStudio, you can go in and it lets you do this like new project thing. When you're in a project in RStudio, you move from one project to another, it will remember what scripts you had open, all the files open, what the working directory is, and it will automatically do that, and it will show you the files within the directories associated with that project. So like this class and the package for this class, I use our project manager, so I can just flip between them. It will load, if I've got a dozen scripts open simultaneously, I can move between them. It will open all those files at the same time. That's pretty handy. RStudio is neat. So take advantage of its functionality. Okay. And then just some clarifications on files, because I always kind of get questions on this sort of thing. In this particular class, we're mainly working with three file types. We're working with .rmd files, which are markdown syntax files. So this is where you write code and text that you're going to use to make a document, right? So we work with markdown documents. You turn these in with your homeworks. There are .r files, which are R syntax files. This is where you write code to process and analyze data without making some sort of output document like an HTML file or a PDF. Lastly, you have a .html or .pdf file, which are the documents you create when you knit those RMD files. These are the three main files we deal with in this class, and generally when you program in R, those are the three main types of files you're going to deal with. In addition, you'll also work with .r data files, but this is pretty much about it. Okay. Any questions about file types or anything? Or anything I've just said? Good. Cool. Yeah. Be sure you understand that. And never be afraid to ask for clarification. If you think something is a dumb question, it's usually, one, not a dumb question, and two, I'm going to be real excited to answer it because it's probably something fun to talk about. So sorry if that happens, but it does. Okay. So, now we're going to move on to our ggplot unit. So, we're going to be talking about ggplot and plotting today. So, first, I want to talk about the data we're going to use for this. So, we're going to be using these Gapminder data, which is a clean, nice data set that has a hierarchical structure that's really good for displaying plots. This is not built into R, however. So, what I want everyone to do in their RStudio, in their console, I would like you to type install.packages and in quotes Gapminder. That's going to tell R, of course, to go look on CRAN, the central R repository for all packages, for something called Gapminder. If it finds an exact match for a name, it's going to download that package and install it to the computer. Okay. Then I want you guys to do library Gapminder. So you can put this if you want in a script, and when you work on your homework this week that uses these Gapminder data, you'll put library Gapminder in there. You only have to run install packages once, and in your console, library you'll have to load at the start of your RMD file or your syntax file every time you want to access it. So you'll always load libraries normally at the very beginning of a markdown document or a syntax document. You'll load all the libraries you use. Sometimes you're going to load a lot of libraries. In this class, there's homeworks where I'm going to expect you to load 5, 6, 7, 8 libraries. In practical work, sometimes you're going to be loading so many libraries that you actually have a second source file you load that has all the library commands in it, so you don't have to type the damn things out every time. I do that all the time. You guys learn how to do that later in the class. It's really easy.
I have a question.
Yeah.
Versioning, as far as R is concerned.
Yeah.
I've noticed here, when I was trying R by myself, it says, warning, this was built under a different R version. Mm-hmm. And I'd be like, oh.
Yeah, you've anticipated my next slide.
But,
yes, you're right. But versioning is something that luckily doesn't usually matter too much in R, but I'll talk about that here in a second. So, before we get to the version thing, if you type in this, str Gapminder, this will give you the structure of the Gapminder data set. And you can take a look at what this does. And of course, you will have had to do library gapminder first, then you can run structure gapminder. What you're going to see from the structure command is a lot of information on this data frame, and I'll disassemble this a little bit. So, what this is saying is that this gapminder object, the data frame, has these classes. It is a data frame, however, it is also two other things. It is a tibble, which we're going to talk about mostly next week, and it's a tibble data frame. Tibble is a type of data frame that is specifically shaped and ready for use with ggplot and dplyr, but it functions and looks just like a data frame. This tells R that it can be used for particular operations that require a tibble or a tibble df. Doesn't matter too much now, but it's something nice to know later. Next, you'll see that gapminder contains these variables here. There's 6 variables inside it. Country, continent, year, life expectancy, population, GDP per capita, and then these are the first values to it. Now, this here is what type of variable it is or what type of data is stored in that particular element of this data frame. There are 2 things called factors, which we're going to talk about here in a second. Then there's integer data, there's numeric data. Okay? These are about the 3 of the 4 most common data types you'll encounter in R. The other one is character data just being raw text. Okay. So, what's interesting about this data frame? First, we have these factor variables that are country and continent. What a factor variable is it is a type of categorical data that's being stored with some sort of underlying numeric representation. The way that usually works is, let's say that we had something like countries in North America, and we have Mexico, Canada, the United States. That would just be like taking Mexico, replacing it with the number 1, Canada, replacing it with the number 2, and United States, and replacing it with the number 3, right? That's all a factor is doing. It's still Canada, the United States, and Mexico. By being stored as a factor, R knows not to treat it like an actual numeric thing. You can't do math with a factor because R is like, okay, there's a numeric representation that allows you to call on things by 1, 2, and 3, so you're not typing out those whole names, but I'm not going to allow you to add them because adding the United States to Mexico is meaningless numerically, right? So factors are for categorical data. We're going to talk a lot about factors, I think, in week 7. Okay, and in social science, you work with a ton of factor data, so it's really important to know how to deal with factors. The next, there's a lot of observations. There's 1,704 rows in this data frame. It's not a huge data set, but it's enough that you can't look at the whole thing at the same time, so we're going to need to do stuff with it to make sense of it. We can't just glance at the whole thing at once. Next, it has a nested or hierarchical structure. There are years for each country and the multiple countries represented in each continent. Right? So there's tiers to the data. Okay. Next, before we can start, yes?
Is the nested, the last observation, is that something you know from running that structure command, or just you know?
We just know.
What the data frame
And the reason we know is we look over here and we kind of look at the variables and you're like, okay, I see country. We have listed here like Afghanistan, or if you, it might be easier to see if you had, see how it's Afghanistan is the first level of the factor. So what this is showing here is there's 142 levels to this country thing, meaning there's 142 countries represented in here, but they've been replaced with a numeric representation. Afghanistan is the first level, and the fact that there's 1, 1, 1, 1, 1 means that these are all Afghanistan. But then I look down at year and I see 1952, 57, 62, 67, 72. So if I glanced at that quickly, I'd be like, oh, okay, there's multiple year observations for Afghanistan. And I look down in continent, and we've got like Africa, Americas, the next one here would be Asia. There's 3, and I see that 3, 3, 3, 3, 3, 3, 3, meaning all the Afghanistan observations are found in Asia, they're across years. This is what we would call like a country year data set. So it's actually a type of panel data, if you've ever heard that term being used, or if you've taken a panel data class. This is a type of panel data. Statistically, panel data is kind of hard to work with. Visualization-wise, it's super easy to work with, and it's really cool, so this is why we're going to use it as an example. But yeah, that's something you just know by kind of glancing at the data. You get a feel for that stuff over time as you spend more time looking at data. Sometimes you just look and be like, I'll know exactly what that is. Yeah. Okay, great question. So, before we could start visualizing things, I want to talk about subsetting data. So we want to be able to basically select what we're going to actually visualize, and the way to do that is with subsetting. So the way we're going to subset things is not using base R commands, but rather we're going to use sort of the modern standard for subsetting data, which is something built into the package dplyr. Dplyr, ggplot, and most other packages used in this class are part of an overarching set of packages called the tidyverse. Tidyverse has a major web page you can look at to see all the different packages that are a part of it. What I want you guys to do here is I want you to, in your console, type install.packages tidyverse. Okay. What we're going to do is install this, which actually contains a ton of different R packages, almost all of them being the very best packages out there for doing whatever it is they do. These are the industry standard packages. They're very well maintained by a very large number of people working for our studio and also at universities around the world. They're great. Their syntax is uniform and they all know how to interact with each other. It's great. So, today we're just going to be talking about two parts of the tidyverse. First here I'm going to be talking about dplyr, which is this really powerful package that we use for sort of shaping data, but we're only going to use it for filtering or subsetting data today. We're also going to talk about ggplot later. So, installing it might take a minute. It's okay if it does. I'll try and slow down right here for a second. So what I want people to do is once the tidyverse is installed, do library dplyr, and this is where the versioning stuff pops up. So if we do library dplyr, the first thing it's going to do is it's going to kick out what looks like a bunch of error messages. Right? It's going to say attaching package dplyr, and that's going to usually say the following objects are masked from package stats, filter lag, and the following objects are masked from package base. Intersect, set difference, set equal, union. It's like, what the hell does that gibberish mean? Did this thing break the very first time I loaded it? The answer is no. Instead, what R is doing here, R is letting you know when important things happen, and this could potentially be an important thing. What's going on here is that dplyr has loaded some functions that have the same name as functions that already exist in other R packages. So what it does is it masks over them. That being, if you now type those commands, instead of referring to the ones that were originally loaded, it's going to load the dplyr versions of that. The reason that's done is because dplyr has replaced those functions in base R with ones that typically operate the same way, but better in some particular way, whether that be much faster because the code is not written in R, but rather written in C++ under the hood, or because the syntax is cleaner and more intuitive. What it's doing is it's just putting its own functions on top of it. This is really common. Sometimes you're even going to want to run functions that have the same name from two different packages in the same script, and you have to call on them directly to a package. And you do that by typing the package name like dplyr, : the function name. If you do that, you don't even have to load the package to run the function. We'll talk about that more later in the term, but you can do that. R is just letting you know it's doing this, so that if you then run it and get some error, you can be like, oh, well, I should have known that I couldn't run that function because I already masked over it, right? Now, if you load dplyr at the start of your R markdown, it's going to put that error in your markdown document saying that I've masked these things. So what you want to do is on the very first chunk, I usually make the first chunk of any markdown file R space setup, and I do all of my library loading there. If you don't want that message to show, you can do message equals false. It will hide that output. So these slides, they load dplyr at the beginning of it, but they don't show anything because I've done message equals false. In fact, I've taken another step beyond that, and I've done a command called include equals false, which is even better. That hides everything produced by the chunk in its entirety. It's a good thing to start your setup chunk with. Other times, you're going to get a versioning message when you load a package. You're going to get something like this. Warning, package Gapminder was built under R version 3.2.3. You can tell I made these slides last year, or this particular slide last year, because I haven't changed that. The current version is 3.4.2. You might get this. The main function of this is just to let you know your R is probably out of date. So if it was written or if it was compiled under a version of R that's older than the one you're using, it will not kick a warning, because newer versions of R will always support older stuff. However, if it's written in something newer, it may have functionality that your current R does not support. Typically, what'll happen is you'll update all the packages in your R installation, and suddenly you'll like compile a script, and every damn package in there is going to say, oh, this was built under R version, exactly one version higher than your current version. That's R's nagging way of telling you, install the new version of R, otherwise I'm going to scream at you every time you load a package. It's just a good warning. Yeah.
Can you install the newest version of R with RStudio?
With it?
Or like, yeah. how-
Within RStudio?
Yeah, in RStudio.
Yeah, you actually can. So typically I manually install it. Like I usually manually install R and then I copy my libraries over just by like copy pasting. There is a package, an R package for installing R. It's called Installer. You can like, I forget, I'm pretty sure it's just install R, no E in it. And you can use it to automate the process of installing R. I don't love that package, but it works well on most computers. It doesn't work well for me because I have my R installation on a cloud drive, and every once in a while it does something weird and gets grumpy because I'm running R on like 4 machines simultaneously from the same location. It gets a little grumpy with me. But if you're in a normal situation, like a normal human being, installer works great. But I find it just as easy to manually download it, install it, and copy my libraries over. Whatever works for you. But installer package, yeah, Google it, you'll find it. It's pretty good. It's good for doing it quickly, just doing it walking away. Yeah. Okay.
Yeah, that's what I got last night. It's
Okay.
not available
So,
for
dplyr has built into it another package that's really cool called Magreeter. Magreet R lets you use these operators called Magreet operators. If you're familiar with art, it's a joke. These are not pipes, and the package is Magreet. These are used for piping data between functions. So normally the way I've written R code in this class looks something like this. Let's say that what we want is we want the log of the mean of population in our gapminder data set. I might do something like gapminder $population, use $sign to call in a variable inside a data frame, take the mean of that, and then log it here. Okay. Well, that means that code in R, if you nest it like this, is read inside out. You begin with the data here, you run this function, and the last function that's run is whatever's on the outside of that. Well, most of us don't read things inside out. That's the result you get there. Instead, if you use Magreet operators loaded into R, you can pipe things from one function to another. Instead, we would write the exact same code this way. We'd say, I want to start with the gapminder population variable. I want to send this to the function mean. Then whatever's the output of mean, I want to send to the log function. Gets the same result, except it's read left to right. So the way we would read this is we would say, send the gapminder pop to mean, then send the output of that to log. Pipes read left to right, while nested functions read inside out. So piping is really good if you want to chain lots of things together that would rapidly get confusing reading them inside out. dplyr is built around the idea of chaining commands together like this rather than doing them inside out because it makes for really readable code. One of the reasons it makes for readable code is at the end of each of these pipes, you can do a line break and go to the next line and it will feed it down. So what I do is I put one command on each line of it. I might, without ever saving an object, I might run 100 more commands on an entire data frame to process like every part of it, and they just feed one into the other till they get to the end. You start with something up here at the top and left, and then you just pump through all of them. This is the way that code is basically written by most people in R nowadays. It's not even part of base R, but it works really well, and it makes your code way more readable than nesting functions inside each other. And piping things like this is the way that, in general, proper programmers will be doing things in their shell scripts and things like that. Piping you input into some function, the output of that function is the input to another thing, and you send them along. If you take a class like Emilio Zagani's big data class, which is actually going on this term, he teaches you guys about piping things around in bash shells. I don't know if you're in it, you haven't got into it yet, but you will later in it. It's really cool. Works the same way. These aren't actually pipes the way a pipe works in a console, but they look like it and they mostly behave like it. Under the hood, what's actually going on in these pipes is whatever is the the output of the left side here, so if we do this, it would be the gapminder data. This just becomes the first argument to this function. So let's say you wanted to do mean, but you wanted to add another argument to it. You would just have mean, and then the second argument equals that, and it would pipe it into the first location of mean. You'll get lots of examples of this, because we're going to be using this syntax for the entire rest of the class. All the code in this class is going to be written using this dplyr syntax. Now, this is probably, for many of you, a little bit confusing. It's okay. All of next week is going to be spent on this, but for now, we just need to know it works, and it looks like that. So, that's what's going on. Okay. You can use dplyr to filter data frames. And what filter means in dplyr is to select particular rows of a data set. If you want to filter, say, this gapminder data set to be only the country Oman, we would do it like this. Gapminder, pipe it to the filter command, and then say country equals Oman. It's then going to give you all of the observations of Oman in the data set, which should be 6 variables wide, 12 observations long, in 5-year increments, starting in 1952 to 2007. Pretty easy. You're like, okay, I want this particular thing. Now, you might ask, how do we actually do that? How does this work? What is double equals up here? So, the double equals is what we refer to as a logical operator in programming, or Boolean logic statements. So the way this is we use equals equals to test, does this thing on the left equal this thing on the right? In this case, we said country equals Oman. The way that works is we want it to say, to look in the entire data set, anytime country does not equal Oman, it returns a false. When country does equal Oman, it returns a true, and it just drops every observation that has a false attached to it. This will make more sense as we continue on through the class. We're going to spend way too much time talking about logic later, because logic is the basis for all programming. But, important to know, there are a lot of other logical operators we can use. Let's say we wanted to just omit Oman from the data and keep every other observation. Instead of double equals, we would do bang equals. Exclamation point in programming terminology is bang. But so exclamation point equals, that means not equal to. We could use greater than and less than, greater than and equal to signs for numerical type things. Like let's say we wanted to get rid of all years after 1965. We would just say filter year less than 1965. It would get rid of all of those older ones. So that's a type of logical statement. There's also another one in R called %in%. We can use this if we want to check whether something is equal to multiple values simultaneously. The way this would work is instead of doing something like equals Oman, we'd say %in and then give it a vector of countries. We could say like, oh, we just want to see countries in the Middle East. So Middle East or the general Persian Gulf area. We might do something like, Oman, Yemen, all the Saudi Arabia or whatever, all those, but we'd have to give it to it in a vector. To do that, you'd do C, the function C, in parentheses, the names in quotation marks separated by commas. So you give it a vector. There'll be examples of that, I think, today and a ton next week. So it's okay if it doesn't make immediate sense. Just know there's this function %in, which is basically equals for multiple items. We can also combine logical conditions, combine them a lot. So we'd use things like and. So let's say we wanted to get the country Oman, but only Oman in years after 1965. We would say country equals Oman and year greater than 1965. It's only going to return a true when both of those statements are true at the same time. We can use this as the or. This is actually called pipe. Because this is reserved for or statements in R, we can't use it as a pipe operator. Whatever. But I'll just call this or. Use this whenever either one condition, either of two conditions or any number of conditions, if any of them are true, it will return a true. This is good if you have some particular case where it's like, okay, I want, the country Oman in all years, and then I only want like 1 year of every other country. You'd be like, give me country equals Oman or year equals 1952. Might be reasons you'd want that. Okay. And also lastly, Exclamation point will negate any logical condition and reverse the true false to it. So if you put some sort of logical condition in parentheses and you put an exclamation point in front of it, it will reverse whatever's the product of that. Comes up once in a while. Doesn't matter if you can't think of any reason to use it now. It's good to know that it can happen. Okay, so millions of logical statements. Programming is built on making logical statements, built on trues, falses. It's built on ones and zeros, which are representations of true and false. Going to be using logical statements a lot. So here's an example of using multiple conditions. So let's say we wanted all the observations in the Gapminder data set for the country Oman that exist after 1980, up through and including, but not after the year 2000. Could do something like this. Gapminder, pipe, and you see how I went to a new line? If you break after this pipe operator, it'll just keep running the code lower so you can space your code out. Filter, country equals Oman, and year greater than 1980, and year less than or equal to 2000. These are the data you get. You get nothing but the observations for Oman, and only the ones of the years after 1980. And before 2000. So you can string these conditions together to get exactly what you want.
Is it just good practice to nest all of those different conditions into their own parentheses?
Yeah, it's just, that's actually just as an example I did here to make it clear. You do not need to put those in parentheses, each one of those. R knows that equals refers this object to that, and then the and is for connecting multiple statements. It knows that. If you're going to do a bunch of them, sometimes it's nice to put in parentheses. Like in this class, I'll do examples and use more parentheses than necessary so my code is clearer, but you absolutely don't have to. Yeah. Okay. Anyone have questions about that? Yeah.
You have to put the code on different lines.
No. You could put it all on one really long line. I just break it up so it's a little bit more readable. Line breaks do matter in R in that R will run code line by line, except when the line ends in an operator of some kind. The pipe is an operator, so if you break a line after it, it will keep running the code below it as a single line. If this was not there, it will just run it line by line. R executes line by line like that. Just knows that if you want an operator there, it's kind of like how if we typed out in parentheses 2 plus 2 and left the right parenthesis off, R will be like, oh, you're not done yet, give me something. It's the same thing, because the parentheses are actually an operator in R that are saying run things inside them first. If you finish with a plus sign and nothing following it, R is going to be like, oh, continue going it, because the plus sign is an operator in R. Yeah, which is going to matter a lot for GGplot, because GGplot is built using lots of plus signs, which allow you to run things on multiple lines. Yeah, great question.
Can you nest? I've used regular expressions to subset. Can you nest regular expressions?
Yes.
in dplyr?
You can, yeah, dplyr plays
I think I
real
did that by
nice.
accident once, but I wasn't sure that
Yeah.
that was good practice.
We have half of a day on regular expressions in week 8, one of my favorite topics, because everyone in social sciences deals with text data a lot. Regular expressions are sort of the language of text logic. It's really good for dealing with things. dplyr plays nice with regular expressions. We'll talk about it a ton
But
later.
it's seeing Oman as a factor, not a character,
So
right?
it is seen as a factor, but you can look at it either numerically or as character data.
Well,
It,
you convert it, right?
Yes.
to character
yeah.
data. But because it's seeing it as factor, using a regular expression would be problematic here. So using the logical expression makes more sense.
No, it'll do it either way. So R will, R and dplyr and the function subset, it might be a factor, but if you do something with it that's meant to be done on character data, it will treat that factor as character data, because it knows that that's what you want to do with factors. So a factor is both character and numeric at the same time, and if you give it a numeric function, it treats it as numeric, and if you give it a character function, it treats it like character. So I could do, I could just do filter and then a regular expression that returns true when it locates the text Oman, and I could do that with like a grepl, which is logical grep. I could do that, and it would return the exact same thing as doing equals Oman. It just works. Magic. It's not really magic, there's a lot going under the hood. You guys will learn that. So, cool. Next. Maybe we want to save some particular subset of data to make it usable throughout the rest of the script that we're working with. To do that, you just use the assignment operator. So, in this case, I just want to save the data for China. on here. What I do is I do gapminder, pipe it to filter, country equals China, but then on the left side of it, I just have assignment to China. Now you might think that if there was a whole bunch of piped stuff going down line after line after line, you might have to put the assignment operator at the end. No, you put it at the start. dplyr reads in a really nicely way. What you want to do is you read it left to right. It's like, I'm going to create an object called China. What I want China to be is the result of anything I put after that assignment operator. So it's like, China is going to be the gapminder data filtered to have country equals China, and I could have many, many lines of code as long as it's piping all down here, but the assignment would still occur up there. dplyr is nice, it reads left to right. So, now I could do head China, which will display the first 4 lines of these China data, and I'm going to get this, because I've saved it as an object in my local environment. I haven't saved it to the disk, but it's in my environment and I can access it.
So you create a new variable called China. And
Yeah,
then
well, it's not a variable, but it's an object,
Okay.
and the object that it is, it's a variable in the programming sense of being something, but in fact is this whole data frame, right? But yeah, I've created a new object. In R, the best term to use is objects, because when in doubt, it's going to be an object in R. Everything is an object in R. China's an object in R. This is an object in R, made up of 2 different objects. That's an object, that's an object, that's not. It's all objects. So it's meaningless in R, but it's true when you say it. Yeah. So, yeah, and now China exists in this particular environment I'm working on. I can call on it. Yeah.
What does head do?
Head. Head's a command I introduced very briefly last week. All head does is you give head 1 argument, it displays the first 6 observations of it, or the first 6 elements, or you give it what you want to display and then comma and then the number of elements you want to display, and it displays that many. There's a companion to it called tail that displays the end observations. Head and tail are just good for doing a quick glimpse at your data. Great question.
Maybe you're going to talk about this, but I'm just wondering what the difference between the data frame and a table.
Yeah. For all intents and purposes, nothing. But what it is it's a class that tells other functions in R that thing's already gone through, like dplyr functions. So it has some certain things stripped off of it, like row numbers or row names have been stripped off of it, a couple other things. Basically, it's just saying this is something that's been a product of a dplyr function or some other tidyverse thing. It matters most to know that if you get into the real nuts and bolts of programming using tidyverse functions, what tibbles add to things or do not. But it's basically just has to do with how the data are stored and shaped. For anything in this class, it doesn't matter. But if you're interested, you can look it up. There's a package, Tibble, that's just for creating these objects, and it kind of tells you the nuances of it. And there's some stuff to it that makes them a little different from other data frames, but anything that works on a data frame works on a Tibble, because it's a type of data frame. Data frames are a type of list. Tibbles are a type of data frame. Tibble data frames are, it's many different names. These are what we call a class in R. Classes are for telling other functions how to treat this object. That's all they are for. Yeah. But yeah, one of the main things is that if you enter a data frame, like if China was a data frame and you just entered the name of it in the console and hit enter, it would print the entire data frame. The print function, when you type in China, because it's a Tibble, will only display like the first 6 or 10 observations, because the default way of displaying a Tibble is different than a data frame. It's just little small things like that. That just has to do with the class. Yeah, great question. Okay. So, now we're actually going to plot stuff. We've actually gotten there to our ggplot unit. So, okay. Last week, I showed you guys a couple base plots, which I referred to as ugly plots, because I think they're ugly. They're clean. They're okay. They use syntax that looks something like this. This is just the plot command. By default, the plot command displays scatter plots in R. This is plot life expectancy by year. Read the tilde as by. Tilde is used to designate a formula in R. Regressions are written the same way. Using data China, which I just created before, I'm giving it an X label of year, a Y label of life expectancy, a main title of life expectancy in China. Color red has made the dots in the scatter plot red. CEX1 has scaled the text to 1, which is CX1 is the default, so you could actually drop that. PCH16 is the point size, right? That makes these dots a little bit bigger because the default is about 12 or something like that. You don't need to know much about that kind of stuff. That's base R stuff. A lot of base R has 3-letter acronyms that mean arcane things that you need to punch into it. What matters is that you could run this code and you could get the same thing if you had the China data. We're not going to be using base R plots in this class, basically after this slide. Instead, we're going to be doing something else. Instead, we're going to be using GGplot. So GGplot is an alternative package for plotting things in R that most people in data science, statistics, other disciplines prefer over base graphics, though there are people who, with quite good reasons, prefer to use base graphics. I sometimes mix base graphics and GGplot for a couple reasons, but for most things you're going to do, GGplot is more powerful, easier to use. But this is something that's not part of base R. It is in that tidyverse package I had you all install. If you guys do library GGplot2, that will load up GGplot into your local environment. The idea for GGplot and what the GG stands for is Hadley Wickham had this idea about the grammar of graphics, that the way you should display and create plots is by stringing together essentially nouns and verbs to perform actions and just stringing them together one after another. Instead of, say, in this plot where we have a whole bunch of arguments in here, doing it, instead we're going to make some simple statement and then we're going to say, let's add this to it, add this to it, add this to it. And you just keep adding things to a single object. I'll show you what that looks like in a minute. But the idea is we're breaking it up into elements and just combining different elements where you can add and remove any particular element on the plot very quickly and easily. So here's the GGplot syntax to make essentially that same plot. This is Chinese life expectancy in GGplot. I've done GGplot, data equals China. I have this function here, AES, which stands for aesthetic. I'll talk about what that means. X equals year, Y equals life expectancy, which is clearly set what our axes in the plot are. X is our year, Y is our life expectancy. And then that's the entire function call at the top. And then I've done plus, so operator call means the code continues on the next line, geom_point. What that's saying is I want to take this base foundation for a plot and to it add some geometry, which is points. Basically, I've just created a scatter plot. Notice how there's no arguments inside geom_point. What it does by default is it goes and grabs these x values based on the year or y values based off life expectancy and plots dots on here. Just does it. If I replace geom_point with geom_line, it would take that same stuff and draw a line between all of those points. Okay? So, I'm going to talk some more about this. Quite a bit, actually. So, maybe we want to add axis labels. Play with the points, and get rid of that gray background. So by default, there's a gray background in GGplots. I think that's stupid. I think you should get rid of that. But it's a waste of ink. But anyway, so we want to get rid of that. So here's how we do it. Notice that the first function call never changes when we do it. It's still the same thing as before. Data equals China, aesthetic, x equals year, y equals life expectancy. To modify all these things, we're just adding stuff to that base, that foundation to the GGplot, the initial object we've created. Now what I'm doing is geom_point, but I've added something to it. I've made color equals red and size equals 3. What that's done is it's made the dots red, it's made them size 3. But I haven't done anything else to it. Then I've said x label, let's make it year, y label, make it life expectancy. Make the title, GG title, life expectancy in China, and then add a theme to it. And the theme I've used is theme black and white. It's built into GGplot. It's a little bit cleaner. Gets rid of a gray background, but otherwise it's pretty similar. It still has annoying grid lines, but some people like grid lines. Now, see, the way it works is just adding elements to it. And the interesting thing is to remove an element that existed originally in the base, you're still just adding some particular function to it. Okay? So, maybe we want to do something like color all of the observations by a particular variable in our data set. So I'm swapping only one thing in the first function call. I'm still doing, well, I'm doing data gapminder now instead of just China, because I'm going to color things by continent. I'm doing x is year, y is life expectancy, and now I have a new argument I've added in our aesthetic. Color equals continent. What this is going to do is that any other function I run after this on this plot, it knows to color that thing by the continent that those data are associated with. Because the data, ggplot, unlike base R graphics, takes the entire data frame as an argument, so it can access all of the information on all of like the rows of the data and everything. Then I'm doing the same geom point, the same labels and everything, the same theme. Now, what ggplot knows to do now is it's colored all of the observations on this data set by continent, and it's automatically created a legend for it on the right side. So now you see that this is a scatter plot. Unfortunately, because the years are only 1952, 1957, so on and so forth, they're lined up like that. I'll show you how to deal with that a little bit later in this presentation. But it's colored by continent. So Africa's by default, it's become a red. America's a sort of kind of a brown-yellow, I think. Asia's green, so on and so forth. And that's just by adding color equals continent here. So if you have some kind of hierarchical data set, like this Gapminder here, colored by continent or something by country, anything like that, you can just add a command there, and it will tack it on like that. This is something that becomes much harder to do in base graphics pretty quickly, but is trivial to do in ggplot. Okay. You might want to segment the observations in the data sets by some variable. That is, separate them by the values of some variable. What I've done here is the same call up top, basically. I've done aesthetic, year, life expectancy. Now I've added group them by country and color them by continent. I've added a couple other things here. I've connected all of the observations for each continent with a line. Instead of them being scatterplot dots, I've drawn a line. Alpha 0.5 just make them 50% transparent. Alpha is the transparency layer in graphics. Then I've done this thing here, facet wrap tilde continent. What facet wrap does is facet wrap draws one individual plot for every value of that particular variable. There's 5 continents in the data set, so it's drawn 5 plots and put the observations for each of the continents on their own plot. So that's all it takes to stratify a graphic by some particular variable. If you wanted to do it for country, you could do it by country, and it's going to produce 142 plots. It's perfectly happy to do it. Then, yeah, do it.
Can you subset within ggplot?
Yes.
So you could facet with, okay.
Yeah, you could do. Yeah, you can do a
I've done,
lot.
like individual ones before because I couldn't figure out. I kept getting it would puke at me every time.
Yeah, you got to learn sometimes the nuances of doing like the subsetting within, but ggplot, you can do a lot of stuff within it, and we're going to mess with it a little bit over the course of the term. Most of the stuff I'm going to show as examples are relatively simple, except for like some of the stuff at the end of this lecture. I show something that's completely stupid, but you guys will see. So you can stratify by things. This is great if you want to do things like, let's say I want to simultaneously look at the trend, like life expectancy, something common for is like I'm somewhat of a demographer. If I want to look at something like the trends in life expectancy in every country in the world simultaneously grouped by something like continent, I might want to do that and draw 142 plots and pick out ones that will have weird odd spikes. You could just do it, it'll do an entire page of them. It's perfectly happy to do it, and it's fast. Base R graphics does that slowly, and the code is a pain in the ass. This is really nice. Okay, and you can see it's still colored by continent, and it still has this scheme over here. It just means every plot, because we've stratified on continent, has a different color. Yeah.
And the group part, the group thing over there in the country, like if you don't put that, what?
What group country has done is it's told it to make these lines be a line for each country. So by grouping by country, it's drawing a line. So this is one particular country, something like that. That drops at 1994. That's Rwanda. You can see in particular like countries these big drops and things like that. You actually see Africa here has this big tail down here. HIV epidemic in Africa, early 90s, late 90s rather. Yeah, but group here is just told geom line to group the lines by that. Anything you call after here would group it based on country. Yeah. So if I group, you could group the lines. You could group, dots, all kinds of other things. So it passes it on. You could tell geom line and give its own group command in there and group on something else so you can override it. But by default, anything you do in this first call here is going to be passed on to all these other commands. This is something kind of cool. Yeah. First, you're like, there's a lot of crap going on. I don't know what any of this is. This homework is going to be all about sort of figuring that out, and the rest of this lecture is about figuring that out too. So, You've seen a whole bunch of these plot examples, but it doesn't mean you have any idea how any of that is working. So what I want to talk about is what is the structure of an actual ggplot, so a ggplot2 object. So there's two primary components to a ggplot object. There are layers, which are the components of a graph. What we do is we add layers to a graph, layers being things like your axes, your lines, your dots, geom line, geom point, all those are different types of layers. We add them. We're always adding layers to ggplots using a plus sign between each one of them. And that includes lines, shapes, text, axes, labels, tick marks, backgrounds, everything. Those are all elements or all layers that you add to a graphic. Then there are also aesthetics. Aesthetics are the things that determine how those layers actually look. So we set aesthetics using arguments inside of these layer functions. This would include the locations of things in those layers, like an aesthetic would be the location of the dots on a scatter plot. The dots are part of the layer. The locations of those dots are their aesthetic, or the color of them, or the size of them. Aesthetics also determine how data map to appearances. So you can set up something that maps data, like a variable. Say before we had year, if we wanted to make year control an aesthetic, for instance, if you want to control the x location of a dot, that is a aesthetic that you'd set. You'd say aesthetic, the x-axis, so x equals year. That means the x location on the scatter plot is being mapped to that particular variable. Yeah. So these two big components do two very different things. What does it look like? Or what options do we have for this sort of thing? For layers, these which are the components of a graph, we have a lot of different things you can stick on a graph that range from very general things to very specific things. The base layer that we start with is always this ggplot call. That initializes a plot. We have to give it a data frame, some data frame we're going to use for it. Well, actually, technically, you don't have to give it a data frame. You can give a different data frame in each one of these layers, but some data has to come into it at some point. That just specifies the input data. If you want, you could set aesthetics in it too, which I'll get to in the next slide. You could do something like geom point to do scatter plot points. Geom line will do lines. You can do title xlab and ylab to do layers for labels. I think you can do a zlab for doing three-dimensional plots. You can facet wrap or facet grid to facet plots. Facet wrap just runs a plot until it hits the edge of a page and it starts a new line and keeps wrapping them down the page. Facet grid will set it in some particular dimension. So you could say, oh, I want 2 columns of 4 rows of plots. It will do 8 plots laid out in that particular way. So facet grid is what you want to use to do in a particular fashion, and it takes formulas. So for instance, you could say facet grid gender by age group, and it might do gender columns with age group rows. So you can just give it variables too to stratify them like that. And then I did theme black and white, which just replaces the gray background with black and white, but there's a lot of other themes that you can give. You can add new themes to it. So for instance, I think Jeff Rudd on campus has a package called GG Themes that adds themes from major publications like The Economist and particular journals. So you can just do like Theme Economist and copy the plots that they use in their magazine. It's kind of cool. Themes are neat. Okay. Layers are all separated by plus signs, and for clarity, when I do my own coding, I usually put each layer on a new line unless it's something small, like I'll often put all of my labels on one line across, so all my labels are together. You can group them if they're small. Otherwise, I put them all on their own line. As long as the line before it ends in a plus, it's just going to add the next line to it. If something breaks, it might be because you forgot to put a plus on the previous line.
There's an XKCD one.
Oh yeah, there's an XKCD. Yeah, there's a lot of themes for these. Okay, so aesthetics are the other part of ggplot objects. So aesthetics control the appearance of all of these layers, right? Commonly, you'll have something like x and y, which just determine what are the x and y values to use on something like locating dots on a scatter plot. Color is an aesthetic, which will set the color of elements. You could do it either by setting a particular color, by like make everything red, so color equals red, or if you put it in the aesthetic function, which I'll show you guys in a minute, you could set color to be equal to some variable like I did before. Let's color code it by continent, let's color code by country, or something like that. You can also color code things by gradients using numerical variables and things like that. It's pretty neat. Get into it. You can group things, so if you have something, this is typically used with a factor, but you could also use it for some numerical things if it's like integers. You could group things based on some variable. You might also want to control the size of points or lines. Like maybe you have a scatter plot where you're showing some relationship that's not controlled by population, and you want to make the dots bigger or smaller by the population of the country. You might set size equals population, and then be like for countries that you want to say, well, we have more data if it's a country with a big population, so let's make its dot really big or something like that. You can do that kind of stuff.
Can you also include a function in that argument too? Like size equals the standard deviation? Or
Yes.
something?
Yeah, like that. The standard deviation of a variable that exists in there. You can absolutely layer functions into there. Yeah, it's pretty flexible. Now, so there's two different ways to use aesthetics, which I've kind of hinted at to this point. You can set an aesthetic, or you can map an aesthetic. So, layers will take some kind of argument to control their appearance, which are these aesthetics we're talking about, such as their line colors or transparency. I like to mess with transparency a lot if you have tons of data on a particular plot, so you can see everything at once. So, arguments, things like color size, line type, shape, fill, can all be used directly on a layer. We call this setting aesthetics. When you just say, for instance, maybe for a geom point, for a scatter plot, I want every single dot on that scatter plot to be the color red. I would just do color equals red. This is referred to as setting an aesthetic. However, if you put arguments inside of this function, AES, instead of setting it, they become what we refer to as mapping aesthetics. A mapped aesthetic is something whose value depends on a variable we've given it or a function of a variable that we've given it. So, if instead of doing geom point color equals red, I did geom point AES, color equals continent, that's going to make the color of every scatterplot dot in that geom point be different for each continent that's on it. So the difference between setting and mapping, this is the same for everything. This is different for any different value of it, and this has to be put inside this AES aesthetic function. So just remember, things that are going to be modified by the data in some way go in AES, which is why in my examples before you saw my first ggplot call, X, Y, color, group, whatever, are always in that AES call. So even X, Y coordinates, you put them in AES because they're changing the appearance based on a value of a variable. Yeah. So, like I said, AES in the ggplot call, the very first call on the entire plot, will change the aesthetics for every other layer that comes after it. But if you include some aesthetic that is the same argument in it, you can override that. So if you want a plot that mostly uses the same aesthetic, but down at the bottom you do something like you plot another variable over the top of it. For instance, if you're doing something like life expectancy, you also want to plot like women's education, which is a good predictor of life expectancy. You might plot it over the top of it by changing what you're using as the Y variable, but keeping the same X variable. You could change only the Y in that like geom line and plot over the top of it. It will keep all the same stuff before that you didn't override. This is really nice for doing complex plots you might actually want to use in a publication, whereas doing this in base R graphics, you end up with these colossal piles of code that are just impossible to read, and ggplot just makes it so trivial to do. You're just like, I can do anything, I'm all powerful. It's amazing. This is because I didn't use ggplot for the first 2.5 years I was working with R. That was a horrible mistake. Yeah, I'll never get that time back. Okay. So, the difference between mapping and setting, it might sound to some people like I'm being a little pedantic, but what matters is that using precise language makes Googling for answers way easier because the people who know what they're talking about are going to use that precise language. The people on Stack Overflow you want answers from are the people who are calling them setting and mapping aesthetics and things like that. Good language lets you zone on answers really quickly. Another nice thing about ggplot is the community for ggplot is enormous. Probably bigger than base R graphics, so you can get help really, really easily. ggplot is also not nearly as idiosyncratic as base R, so if something breaks, it probably always breaks in that same way for every person, and it's probably not a bug, and you'll be able to find help for it. Base R graphics, sometimes the exact same argument in a function looks exactly the same, does something completely different in those two functions, and breaks in weird ways all the time. Base R graphics are weird. Base R graphics are mostly written in the late 80s, early 90s. It's a mess. Trust me, it's a mess. That's why I have a book on my shelf this big on base R graphics. and my ggplot book is actually just the ggplot cheat sheet. So, yeah, gives you an idea. Okay, so maybe you want to store plots. So, if you want to store plots, you can assign a ggplot to a name. It's an object like anything else. So what you do is, so this is a whole ggplot call like we did before, and much like I was showing with that dplyr example, because every line ends in an operator here, you can just assign it up at the top. So here's a life expectancy plot using that gapminder data, life expectancy on the y-axis, year on the x-axis, colored by continent, with our labels and everything, and I've saved it to a plot called life expectancy by year. I've saved the object. If you do that, it doesn't display it immediately because you've saved the object rather than like printing it to output, right? But that means now if you want to draw that graph later, you call on it just by saying life expectancy by year and it will draw the plot, right? This is the plot I created in that previous one. So you can see all the elements of it that I've done here. Everything's represented here. I'm trying to think what that would be. 1977, Asia, massive drop. Oh. Vietnam
Cambodia.
and Cambodian. Yeah, something like that. Interesting. Then you see things like Africa shifts down at the end. You see Rwanda right there. Anyway, I always like these life expectancy graphs. They're very sad. Anyway, don't get a demography unless you like drinking. Okay, so maybe we want to add another layer to that plot. We don't have to redraw the entire graph using all this functionality we did before, all the commands. We take that object, life expectancy by year, and we just add another layer to it. So I took that object that contains all the previous code we wrote, and I just do plus geom line AES group equals country. I've now made it so every country has a line going between all of those points in it. So you can just tack stuff on to some existing plot. This is great if you have a lot of really similar plots you want to make, but they have just a little bit of differences. You make one base object, you can just tack on for each individual one, and you do it. And then you can also tile all of these individual graphics, like multiple graphics that are very different, into one thing using a package called CowPlot I link to on the webpage. If you have like 6 ggplots that have almost nothing to do with each other, but you want to tile them in a nice pattern, use the CowPlot package. It does it very elegantly. CowPlot also can replace the base ggplot theme with something less like overdone. I don't like grid lines and things, but.
So CowPlot is how you can organize them?
CowPlot will let you organize plots that are not all in the same ggplot command. So if you have a bunch of ones for some reason you can't do all the plots, like they're not faceted and stuff, just very different plots, CowPlot will let you tile them all together. It's very elegant. Okay, so yeah, you can just sort of add layers to it, an existing object. It's really easy, nothing fancy there. Okay, here's some suggestions for tinkering and playing around that I have for you guys, and this leads into homework. It's more or less what I'm going to ask you guys to do on the homework too later. So you might experiment with making graphs in ggplot using this gapminder data. You might do things like filter the data and look at different countries, different years, things like that. Limiting the rows. You might plot different x and y variables. You might facet it by some factor or something like that. But there's a lot of other things you can do that I haven't necessarily covered. There's other geometries like geomhistogram does histograms of numerical data. Density does density plots of numerical data. Box plots are good for doing, like, if you have a numerical variable stratified by a categorical variable, you can do box plots. You can do smooths. Geom smooth does both low S lines, which are like a line of best fit that smooths around points. They're splines, if you've ever heard that term before, or regression lines. So if you want to add a regression line to a plot, you use the geom smooth and then give it a formula for that regression. It will draw it on top of your plot. Another thing I mentioned earlier, so it's not Jeff Rudd, but it's Jeff Arnold's. Jeff Arnold's GG themes package has themes like there's Theme Economist, Stata, Excel, that will make it look like those plots were produced by other pieces of software or from magazines and things like that. He's got a whole bunch of themes in there that are really interesting. So if you work with people who are used to Stata and you want to pretend that you're like a Stata person, you can actually make them look like Stata to blend in on the East Coast or something like that. Like, you know, if you're going to an Ivy League university where they're not teaching R, you can be like, oh, I'm one of you people, and then use theme Stata. Yeah, it's great. Yeah. Well, those things to play with. You can refer back to that slide and give you some ideas. There's a lot more later in this lecture, too. Now I'm going to talk about some like common things you might want to do in data you're working with. So a real common problem with scatter plots is points over plotting. So if you have something like this, where I've got all of the continents here, and I've got observations by year over here, every dot is just plotted right on top of each other. We don't actually know how many observations are on this map because they're all stacked right on top of each other, and we can't see three-dimensionally that some of these dots are sticking way out or not. We can deal with that in a really simple way in ggplot using jittering. So, if you have this, like a problem like this here, add a little bit of a jitter. The way we do that would be in our geom point call we had before, I give it a position, and this is, you'll see what I'm doing here is this isn't an aesthetic, but rather I'm setting this. Position jitter, and I'm just saying jitter things back and forth about 0.5 on average, and up and down about 2 units on average, and it will randomly distribute all of these points throughout this space. Yeah, so you can jitter things if they tend to plot over each other. This is a really common practice when you're dealing with like categorical variables and things you need to plot on something like this. Jitter them so people can see them. You'll want to say in the paper, it's like these have been jittered so they're visible, but people do this all the time and it's a good practice. So what we can see here is that there are just a hell of a lot more observations in Africa and some of these other continents because there's simply more countries in these other continents, right? Over here, there's very few countries. You have New Zealand and Australia and whatnot over here, Papua New Guinea. You don't have much over there. So it tells you something. Yeah. Other things you might want to do, you might want to mess with the axes on a plot. And ggplot is really flexible with regard to what you can do with axes. It's really easy. So maybe you just want to change the x and y range. Like imagine you have a whole bunch of plots that are all plotting more or less the same thing, but each individual country has a different range to it. Maybe you just want to fix and make sure they're all the same range. It's the same range so you can compare a whole bunch of plots next to each other. You could just set x lim and y lim and give it a vector of 2 elements, like the beginning and the end, and that will just be like, oh, go from here to here, and it will scale the axes appropriately for that. You could also do something like, let's say you have data that are really, really skewed in some way. Maybe you want to scale them based on the logarithm or the root of those numbers. Scale x log 10 will put your x axis on a logarithm of 10 scale. This is great for really skewed data. I'll show an example in a minute. Or you might scale your y by the square root. Okay? You could also put where the major and minor breaks are. That's like where tick lines are and where numbers are shown on scales. You can control them with things like scale x continuous. We'll put a scale on your plot on the x-axis for a continuous variable at breaks at the locations you give for major breaks and minor breaks at smaller locations. So big ticks with a number, small ticks without a number for minor breaks. A lot of flexibility. You can do a lot of stuff. You'd specify exact locations or give a function to determine those locations. So, what does it look like? Here's a GDP per capita by year plot for China again. So, my base plot, data China. Aesthetic, X is year, Y is GDP per capita. I've added geom line with no additional commands to it. We just want to plot that as a line. The aesthetic's already determined. I can do it. What I've done, though, is that because the GDP is flying up, and I want to look at like small differences down here, but it's going way up, this would be a plot that would just kind of tail way up. Instead, I've scaled it by the logarithm. I said scale y log 10, so this scale is going up. The distance is going up logarithmically, but I still want to list breaks at 1,000, 2,000, 3,000, 4,000, 5,000. Because it's logarithmic, those numbers are getting closer to each other as they go up, but they're still at the correct locations. This is a pain in the ass to do in base R. It's a joke in ggplot. You just say, oh, do that, and it does it. It figures out everything else. It calculates, it locates everything for you. I've set my x limit here from 1940 to 2010. I don't have any data back here, but maybe I want to plot it all the way back there because I've got other plots next to it that go back to the same point. So I've set a fixed range from 1940 to 2010. Yeah, that's how you mess with axes in ggplot. It's pretty straightforward. Maybe I want to do something like, my fonts were too small. Maybe I want gigantic fonts like I have here. To do that, if I want to change all of the fonts or the base font size for a plot, I just did inside the theme call I did. So theme gray icon here, I just added base size equals 20. That increased the base font size to 20 points. If you want to change individual text sizes, there's a particular argument for every individual piece of text on the entire plot. You can control them all individually, or you can do it all as base size.
really quick.
Yeah.
Can I just have your signature? Turn it over in the class.
Oh, yeah.
With the time conflict.
Gotcha.
Then I'll do it right away. All right.
There you go.
Thanks.
No problem at all. Super.
Yep.
Okay, so let's say we've got, do something like we want to adjust the text and ticks on our particular plot, right? So you can mess with the text size, the labels, the tick marks, all of that with arguments that go in the theme layer in GGplot. And I'll note that the theme layer is not the same as something like theme gray or theme black and white. Theme underscore something sets a whole bunch of aesthetics within the entire plot to make it look a particular way. The general theme function is for manually setting the things that are part of these, like theme black and white. So normally what you want to do is you want to call on like theme gray or theme black and white. Afterwards, call on theme and do your own little modifications to the theme. Right? Okay. So some examples you might put in theme are, you might do like plot title equals element text, and then this is saying size. So what I want to do is I want to make a plot title that's twice as big as usual. So I'm saying plot title equals element text, size, rel2 means relative size 2, twice as large as it is by default. H_just is saying horizontal justification. 0 is left justified, 1 is right justified. I think 0.5 is in the middle. So you can do justification on here. Maybe you want to mess with your axis text for the x-axis. This is something I'm going to do in a subsequent plot. Maybe you just want to put it at an angle. Maybe you have x-axis stuff like years that are wide and you've got a lot of them. Well, maybe we just want to rotate them 45 degrees so they nest in nice. Axis text, x, element text. And you notice how all these ones where I'm messing with the text are all element text function. GGplot's nice like that, where you use the same function for messing with everything of a particular type in it. Element text, I just said angle equals 45. It's a 45-degree angle rotation of the text on the axis. Here, maybe I want to make my text blue. This may be x and y-axis labels blue. I did axis.text. If I don't specify x or y, it does both axes. By specifying x, it did the x-axis. It's straightforward. You kind of tag on periods with more information, and it controls more things. Then here is maybe you want longer axis ticks on a plot, maybe because it's a really big plot, you want people to be able to see the ticks. You could adjust their length or their width, give it some unit. In this case, I said I want them to be ½ a centimeter long. So made my axis ticks longer. So you can do fine adjustments in GGplot. Its defaults are really good for most things, but if you really want to dial it in, like you have a vision for the perfect plot, you can dial in every little thing in GGplot. You add a lot of code to it, but keep in mind, you can also just make an object and then tack on little changes to it. It's fun. You know, you don't have to do it all in one big call. Okay. We can also do things like use scales and create scales for different aesthetics. Usually this is commonly done with color, but you can do it for other things. But scales will control how a mapped aesthetic, so how a variable translates into something like color. So instead of just being like, oh, we have a factor variable that goes to these particular colors, maybe you want to specify the colors, or maybe you have a numeric variable that you want to have it go from like a number from 0 to 1,000,000, but you want it to be split into shades from white to black. So you've got gray shades for it. You do that using scales. The way we do that is you'll have some kind of function that is a layer that'll be scale underscore a particular aesthetic that we want to do underscore a particular option for it. So for example, we might do something like scale line type manual to do manually specifying the line type for every value of a variable. You might do this if you have something like continents 5, you're plotting them all on top of each other. You want to make every line a little bit different. One's a dotted line, one's a dashed line, one's a solid line. You can manually specify it. You could also do it so it's scale, line type, and I think it's, I forget what the actual one is for categorical data. Might be underscore factor or something like that. But you can specify it and be like, oh, well, we'll automatically know it's getting categorical data, so it will just take the first 5 line types that it normally uses, which are going to be like, if there's 2 line types, it takes the most different 2. If you take 3, it takes the sort of the 3 most different from each other, so on and so forth, and it will automatically choose them. So you don't necessarily have to manually do them. Scale alpha continuous would do something where it varies the transparency of something that's been plotted on this plot based on some range. So again, like let's say you have a whole bunch of observations plotted on a plot, but maybe you want to make them more transparent if the data are less reliable. So things that have a really large standard error or something like that, you make them more transparent to be like, I want people to pay less attention to that. Something with a really precise estimate could be solid. It's a neat use of alpha levels. You also can call out with particular, there's a package called Color Brewer that provides palettes that are tailored for particular things, including things for like, oh, I want to make sure that my colorblind readers don't get confused by colors on my plot. You can use ones that are tailored for that. Or I want to use, maybe I have 8 values and I want to go 8 values all the way around a color wheel to get things so they're evenly spaced, most different from each other, 8 particular colors. You could call on Color Brewer and will automatically pick out colors that are spaced around like a color wheel. Perfectly. I call that using Scale Color Brewer, and then Color Brewer has particular named palettes you can use, or you can make Color Brewer create a new palette for you based on specifications you give it. Color Brewer has a web page that you can go to and look at it. It's really neat. If you take Chris Adoff's visualization class, they use Color Brewer a lot, and they talk about choosing good color palettes for showing things, especially for like plotting data. Yeah, so you can get pretty sophisticated with it.
Do you have a question? Do you know if you use a theme and you try using Color Brewer, if will they clash? I've had a problem where it will still make my plot, but it won't draw from Color Brewer because it seems like maybe the theme has got
So in GGplot anyway, the theme will never control the coloration of the actual like data points and stuff.
Okay.
It's not meant to do, well, I mean, okay, it can cover the base color, like there's some plots that will change like everything is blue type thing. But any aesthetic overridden after that theme is applied should overwrite it. And normally we'd be using Color Brewer for something that's in a scale or something like that, which it should always overwrite it. If you wanted to use Color Brewer to determine the overall aesthetic for an entire plot, that would be more sophisticated, and probably what I would use is I generate a palette with Color Brewer and then I'd manually assign values to it because that's doing it in multiple functions on it. You can get pretty crazy with it, but it shouldn't conflict. If you run into a problem like that, email me, let me know, and if I see something worth noting, I'll send it out to the whole class. So it shouldn't be a problem.
I was trying to do it with our homework.
Oh, okay.
Last one, and I was using a theme. And,
Oh, was it a GGplot theme, or was it a theme for the
no,
R
it was a
Markdown?
theme for the R Markdown.
Ah, yeah, okay,
And
that can
that's
fuck
where
some
I
shit up.
Ran into, I was like, God damn it! So I gave up, and I just used like the default blue. And
Was it messing up the plot?
no, it wasn't messing up the plot, but I couldn't change the color, so I just gave up.
Yeah, okay. So the thing with Markdown documents is the way Markdown documents that output to HTML produce, their themes are actually a series of cascading style sheets that are loaded as an external file. So it's actually kind of a pain because you're trying to essentially override what the cascading style sheet is
There's no
trying to
way to
format the doc.
say-
There is if you feel like writing the HTML into the document yourself or modifying the style sheets. It's kind of a pain, so I usually will take a theme and then not modify it too much. It can be touchy, and the more rigid the theme is as far as the way it's programmed, the harder it's going to be to modify it. So most likely what it was is that the style sheet was just not real flexible, and so it was hard to like override or deal with it. I don't know a lot about document formatting myself. I'm a LaTeX guy or I'm an HTML guy, so I'm not great with that, but I'm sure you could poke around and figure something out. It might just be that the theme is inflexible.
Yeah.
Yeah. So, who knows? Luckily, that shouldn't happen for plots. I go. Okay. So, here's an example with legend names and manual color scales that I've added here. So I had our plot before, life expectancy by year, and now I've added to it scale color manual. The name on here is going to be whatever's the title here for the legend, and then I've set values manually. So it goes values equal, then inside a vector, see, I've said Africa, I want to be colored sea green, the Americas, turquoise 1, Asia, royal blue, Europe, violet red, so on and so forth. You can actually manually set the values. That's the syntax for it. You can see the colors over here have been set to those particular values. If you do question mark colors in R, you can get like a readout of all the colors. There's thousands of named colors you can use, or you can call on hex values, RGB values, whatever you want if you want to call them things specifically. Now, this is how you would manually set that stuff. So, here's an insane example for going kind of deep with GGplot. So, I'm doing a really fussy manual legend for a particular plot. If you want to, you can delve into this code and see what's going on. I'll just give a kind of a brief overview of what's going on. I'm using our Gapminder data. X year, Y is life expectancy. I've grouped them by the country. Then I've done G-online, 50% transparent. It's colored based on country, and its size is based on country. G-online down here, I've added a smooth, which is a low S curve, so I'm drawing a different line over the top of these other lines that's based on a spline running through the data. The aesthetic, I've grouped it by continent, so the lines are going to represent continents rather than countries. I've colored it based on which continent. Size is continent. Made it 50% transparent. I facet wrapped the entire graph so every continent has its own plot. Only 2 rows, so it's going to make it as many columns necessary to put everything on 2 rows. I've created a manual color scale where name is unit. I forget exactly what I did that way. The values are countries are black, continents are Dodge or blue. So this is I'm doing here is I'm saying that all of the lines that are lines for a country, which is this geom line up here, I want all those lines to be black. All of the lines that are attached to a whole continent, which are these low S smooth lines across all the continents, I want those to be blue. Then I've scaled it based on these units. So the country, the line is going to be 1 pixel or 1 point wide. The continent ones are going to be 3 times as wide. I have swapped it to the minimal theme with a base font size of 16. And then I've moved my legend because I want it in a slightly different place. And I've put my x-axis text at a 45-degree angle because they were overlapping when I first drew this plot. That is a shit ton of syntax. What does it look like? This is the plot that I've drawn. Now what we have is life expectancy by year for all 5 continents, where every country is represented with its own line. Plotted over the top of those countries in blue is the continent's average using a low S smooth. So this is basically the running average of life expectancy over the top of all these individual countries. I have the years plotted on the bottom at a 45-degree angle, stratified by all of the continents. So you can do a lot. Yeah.
How do you know where the legend is for
Oh, I just messed with it a few times. Yeah. When in doubt, when you're tweaking, like, if you're using absolute locations, I just mess with the values, re-render the plot over and over again until it's exactly where I wanted it. There was no good reason to do it exactly that location. I think I just wanted to, it was originally going to be over on the side, and I just wanted to nestle it in right here where there would have been a 6th continent if there was a 6th continent on here. Yeah, and that's just a legend saying that big and blue is the continent and then black is the country. I didn't change like the axis titles or give it a main title or anything, but that's a lot of the features that we saw here. So you can do a lot of stuff, you can layer it all on. Get a little complicated if you go nuts. So, let's say you did a plot like this, and it shows all this stuff. You might do something like then, be like, okay, well, I want to know what the hell had these huge drops here in the 70s and huge drop over here. You could use filter to be like, okay, give me any country that dipped below like this level here, and it would filter out, and you could use it in subset cases. So commonly when you're working with data in some way, you might do plots like this just to explore, and then it gives you an idea for what else to go back and look at. So you should always be, when you're working with data, you should be jumping between like doing some descriptive statistics, some visualization, getting an idea about it, and then going back and starting the process over until you're zoning in on what you actually want to know about your data or whatever you're working with. So it's a process, and ggplot makes that a very easy process with these smooth commands that you're going to be using, like that are easy to type out, especially with really nice defaults. Just kind of do it over and over again, and yeah. Worry about making like a nuts plot that's like has a lot of things like all this syntax. Don't do that until like you know what you're looking at, you know what you're doing. This is like the final plot for something. Don't waste lots of time tweaking stuff. ggplot's great for exploring your data. Worry about tweaking it, you know, when you get to the end of something. Yeah.
Do you know of a nice package or anything like that that can export ggplots to like a layer SVG vector graphic format.
Yeah, for outputting into vector graphics. I don't know if by default GGSave will let you do SVGs. I'm sure there's something that will do it. GGSave by default will output to PDF, and I've opened them before in Illustrator and been able to manipulate them layer by layer.
Is it all jumbled though? Kind of like everything's just tossed into one layer?
I forget. It's been quite a while since I messed with it. Yeah, if you want to output them in a nice vector format, I'm sure somebody's got something because it's all being, drawn. Everything's being drawn as its own layer in the underlying grid format. So you've got to be able to extract that in some way to make it modifiable. And honestly, most people who do real nice graphics for publication, especially like magazine people and stuff like that, even if they're using R like that, they're massaging it with Illustrator afterwards. So there's definitely a way to do it. If you see people with really nice looking graphics, like there's actually this poster that I worked on. I wasn't involved in most of the graphics on it. That was presented at CSDE a couple times. It has the most beautiful graphics and stuff on it. And the reason is because the other two people I worked with are really good with Illustrator. And so like I put out nice R plots. I'm like, these are pretty good looking. And they just like rend it apart and make it all beautiful. I'm like, God. So your very final stuff like that, mess with it in some other way. There's nothing wrong, but it's your final product. You want to mess with it as much as possible, make it as good looking in the actual like reproducible way, but for a final publication, you're obviously going to want to massage stuff sometimes, especially if it's for like a public audience. Academics, we don't usually care too much about the appearances. I still like to dazzle once in a while in like articles, but people don't care much. But if you're presenting to a public audience or something like that, it's worth taking that extra step to mess with it. And if you take Chris Adolph's visualization class, he talks about massaging your plots a little bit using Illustrator to tweak little elements and things like that. It's worth doing. Yeah.
When you do your own research, you usually type in all the command like that, or like you have already like your favorite default format, and they just copy and paste.
My favorite format changes every time I sit down to work on something again. There's always something I want to do a little bit different. Yeah, so no, I don't have anything. I have some general ideas for things I typically do, but it's a little bit different all the time. It's evolving constantly. I mean, I do have code I'll often copy and paste from old stuff, but I always modify it pretty extensively. But most of the nuts and bolts of something like this are going to be the same no matter what you do. I mean, with ggplot, you're doing, the only things I'm changing here, like, I'm plotting some lines and stuff over it, but style-wise, the only things on here that's actually stylistically is a little bit of the stuff going on down here with the positioning and the angle of stuff and what colors I've chosen. I might copy and paste all this code and just modify the colors, the sizes of things. Like, this plot here is nothing I would actually use for a proper like presentation or anything like that, because it's kind of ugly and the lines are too big. It looks almost kind of like pencil lead drawn across it. It's wide, it's kind of unclear. There's grid lines back. I get rid of grid lines. I hate grid lines. I'd make it extra, but whatever. But they tweak these things. That's all stuff I do at the end. It's like when I finally got it up to the point. It's kind of like, so I defended my MA just last week basically, and I had up until maybe the third from last draft for my MA, all of my plots were actually just copy paste fixed with fonts straight out of R for all of my my tables rather. Then once I finally got like the thumbs up for anything is when I did the entire thing up in LaTeX, did nice LaTeX tables and everything like that. You never do that stuff early, because if you have to modify it, it's a huge pain in the ass. There are packages that put out LaTeX tables nicely in R. I don't like the way they look, so I don't use them. Instead, I waste hours making tables. But you can do that. But formatting, all that kind of stuff is always the last thing you do. It's the very last thing you do. Otherwise, you'll spend forever tweaking plots and stuff, which I do all the damn time because I can't help myself. I'm like, no, it needs to look a little bit different. 3 hours later, I'm like, fuck, that was due. Yeah. So it goes. Try not to mess with it too much. I understand if you do, though, I get obsessed about it. Anyway, do have more things to talk about. So just a little bit more. So, on customizing legends, we can do things like move our legends around, flip their orientation. If you don't want a legend, remove it. The place to go for tweaking ggplots in general, and especially like legend stuff, is the website for the cookbook for R. If you click on that link, it'll pop up on a website that has basically most of the contents of the actual R cookbook, R graphics cookbook text. It's great. And this is sort of a theme for the course. If you have something that you want to do and you don't know how to do it, don't just poke at it, Google around, you look around. Somebody will have already done it, and they will probably all done it in a beautiful way. And they probably have put their code out and said, yo, take my code. because programmers are generally like that. They've done the labor and they're like, oh, share it, you use it. If it's something really complex, they might want you to credit it. You might cite them if it's something nuts, like a whole package or something. Anyway, but look it up. Great website. So, maybe you want to save ggplots in some particular way. You want to put them out because you want to embed them in a document, or you want to do something else with them. You just want to hand them out. So, when you make an R markdown file and you knit it, any plots you do are automatically saved in .png format in a ping image already in like a figures folder that's in the same folder you've saved your markdown to it. If you do it in HTML, sometimes we'll actually embed them inside instead of putting them in another folder. You can tell it whether you want to embed or not. If you want to save a copy somewhere else, maybe you're just working with a syntax file, there's a command ggsave that will save a particular file. You just do it like this. You'd say, in this case, I saved a file.pdf, so I'm going to make a PDF file. I like to output images as a PDFs very often. PDFs tend to be uniform. They look the same for just about everyone. I have serious concerns about PDF as a proprietary format, but it works really well. You'd say what plot it is you want to save. So this is that life expectancy by year plot I created earlier. Tell it a height and a width in units, inches, so you can do centimeters, inches, pixels, points, whatever. You tell that, you'll output it, you open it up, it'll be those exact dimensions in that exact format. You can put it out as pings, you can put them out as JPEGs, you can put them as PDFs. There's probably other options, and there's probably other packages that will extend them to do other things. I wouldn't be surprised if you could do scalable vector graphics or something like that, SVG files, and things. You probably can. Normally, if you didn't manually set font sizes in the plot, just setting the height and width will scale them appropriately. ggplot has great default scalings for things that were actually made with serious thought about aesthetics, which you cannot say the same about base graphics. People who did base graphics were not concerned at all with these aesthetics. They figured everyone would set them manually. ggplot, they were thinking about these things for the default, so they tend to come out nice. Not always. There's also what I call the bad or non-reproducible way to do an image, which I do regularly, is I display the plot in RStudio in that, I open and blow up the window, and I use the snipping tool in Windows or Screenshot and pull it out and throw it in something. That's how I email images to people because it's super fast. I just copy, put it in. Do it all the time. Yeah, it's non-reproducible, it's bad, but it's fast. If you're only going to use that image once or something like that, use them to get to people quick, screenshot it, shoot up. It's quick and easy. Okay, your homework for this week. What I want you guys to do is I want you to go into that Gapminder data, pick some sort of relationship being maybe the relationship between any two variables, maybe three variables or something like that, and just write up some RMD that investigates something about that question graphically with a lot of plots. So you might do something like subset the data. Maybe you want to look only at Africa, because we did talk a little bit about Africa today. Do whatever you want. So probably subset a little bit, something like that. It's up to you, just something you might be interested in, and honestly, if there's nothing in there you're interested in, that's fine, I understand. Not everybody's interested in life expectancy in Africa. Some of us are. Upload both the RMD and the HTML file. Have about 4 to 8 graphs. More the merrier. If you want to go nuts with stuff, go ahead. And when I say 4 to 8 graphs, if you have something faceted that has like 20 facets on it, that's one graph. That's not 20 graphs, so don't just give me 8 facets there like lazy people. So, all titles, axes, and legends should be labeled clearly. No raw variable names, so adjust those names. I want at least one graph that has a facet wrap or facet grid in it. At least one manually specified legend. That might be the trickiest part of this assignment, but it's worth doing because you're eventually going to want to manually specify a legend, so you want to know how to do it. You can also feel free to play with other, if you want to go a little bit wild. You might want to use histograms, bar charts, do things with vertical and horizontal lines, add smooths, regression lines, do whatever you want you're comfortable with, especially things you might think will be useful to you personally. If you work with a lot of data that you have to do with some particular type of like geometry a lot, use that, play with it, learn how it works. This link here goes to that cheat sheet I showed at the beginning of the class, so might find it useful to you guys. Go for it. In general, the document, as always, should be pleasant for somebody to look at with some modicum of organization. I don't care too much, but don't just lump everything together with no line breaks and be like, here, gaze upon my shit. Write up the observations in words a little bit, a sentence here or there, that's fine. Don't go overboard. The coding is more important, but you want to be able to at least communicate what it is people should be looking at. So if somebody sees a plot, they're like, I have no idea why anyone would plot this. You might explain what it is you're looking at. Use chunk options like echo, results, and include to limit what's shown in that HTML. Make it look good, make it look like a report, but don't break yourselves over it. If you have any questions, as always, email me. I encourage you to work together. If you guys work in groups, that's awesome. Same thing as whole class. Do whatever you want, email me. It's due Tuesday at midnight. I'd suggest getting started a little early on it because learning ggplot, it might take you some time or something like that. And also, we're working with a lot of new packages suddenly. We've got tidyverse, part of that ggplot dplyr. You need to make sure those work on your computer. The gapminder data, need to make sure they work. And if you have any problems with R or something like that, we don't want to be solving them last minute. Peer reviews should go out tonight. Don't worry if you didn't receive them by tonight. Other people probably didn't receive them. Don't worry about it. I'll make sure they go out. So that's good. If you guys have questions, let me know. Yeah.
Yeah, I got a quick question for the teacher. Like, you have a plenty of the cloud for each of the row, right? Is there real data for each of the?
Yes.
Okay, but what is like this one?
That's the same thing, but they're not jittered. So because that just means that all these dots are on top of each other.
Oh,
So if you
okay.
go to this other plot,
Right.
here, whatever is within the general area of that particular year, all of those were just plotted on top of each other, and all I've done is spread them out horizontally and vertically a little
Okay,
bit.
I see. Because normally, like, each one point indicate one data, right?
Yeah.
So you have your horizontal and vertical indicate different, like, year or country.
Yeah. In this case, there's a ton of different countries that all have the same year and
Got it.
continent, and so they're all overplotted. Ah. Down there. Okay, so, oh, well, one thing, so in your R Markdown, you don't want to install packages, tidyverse in the Markdown file. You want to run it in that. Okay. Here you go. You want to come over here a second? Sit down. My back is killing me. Okay. Here, set that down right here, and I'll take a quick peek at it. Yeah, I see that there's something odd going on here. Oh, well, most likely it failed. It probably failed because it's currently in use. So what I'm going to do is I'm going to exit. So can you exit from RStudio?
Yeah. In use meaning
Yeah.
close it.
Yeah, just so save what you want to save. Yeah, you could just hit save everything. It'll save it. Okay, and then open it back up. Okay. And your internet connection is on, right? Okay, good. So now we have a fresh R installation. Install dot packages. Tidyverse. See what it yells at me about. Let's see if I may have to manually specify the repository for it. Okay, no, it worked.
No, okay.
Yeah, so
the
it was
problem
some dependency of dplyr was running, and it couldn't override it while it was open. So usually when I install packages, I make it the very first thing I do when I open up R, because sometimes you get an error like that. Yeah.
One quick technical question. So I think mine is not updated.
Yeah.
So I just need to go to the website and then install the R.
Yeah.
Or, okay.
Yeah. So you go to CRAN, and then
And then I think my system needs updated as well because it said.
if you're not on, so if you might still be on an older version of the Mac OS, it's possible.
Right. Okay.
What are you on? You're
They need higher probably.
Yeah, so you're probably on 10.2. She's
Okay,
actually having that
got
same
it.
problem right there.
Previously, before you talk about GGplot, you just mentioned the cloud last time,
Yeah.
and then we do the cloud live with something. And then I just got a quick question for that called.
Oh, it's actually right over here.
Yeah. Oh, sorry.
Should be right. That's fine. Right there.
This one. So here is that a name or is it a data set? Because
The data set is here.
Right,
So the
exactly.
data frame is China, and these are the variables in the data set.
oh,
So life
okay.
expectancy by year, and so I've done life expectancy on the left side is the y-axis.
Okay.
On the right side of the tilde is year.
But if I just delete this one, like plot data, and then
It won't know what to do, and it will give you an error.
Oh, okay. I have to do this one first.
Yeah, for base graphics.
Like life expectancy by year.
Yeah.
Okay.
You could also do X equals life expectancy, Y, or
Oh,
Y
I see.
equals that. I did it using a formula because that's one way you can do it, but
Right.
it's equivalent to saying Y equals that and X equals that.
So this is a Y and then this
Yeah.
X. Okay, got it. Thank
Yep.
you.
No problem. Oh, kill this really quick. Stop recording.